All right, starting now our last section of chapter 2, we have absolute value equations and inequalities. Now there's a duration of how you actually come up with these three cases. I'm not going to go through the actual case of like where these rules come from, but there's a logical progression of these. But I'm just going to go ahead and just give you the three rules so we can just start seeing how these three problems can be completed. Okay, so first of all, let's start with an absolute value equation. So again, this is called an absolute value because of the vertical bars, and it's an equation because it has equal sign. So anytime that you have an absolute value equation that looks like this, you have an absolute value on one side, and then you have a constant number on the other side. The way that you solve this is you have ax plus b equals k, which is our first one. And you put or, you have ax plus b, and then you have the opposite of this, which is negative k. So you go ahead and you solve for x for both of them, and whatever your answer is just going to be a point on the number line. It's not going to be a number of values because we're only looking for one value, like x equals 2, x equals negative 3. So that's why you're only going to have 2 points right there. Okay. The second case is when the absolute value is greater than k. And what I want you to make a note of is that think of this right here when it says greater than kind of almost has the word or in there, greater. Okay, like I know it's greater than, greater, but I think of like greater than. So that's why the way that we set this up is we're going to use the or. We have the or case, and you have ax plus b is greater than k. Okay, so that's right here. And then ax plus b is less than negative k, so you flip the inequality and you also take the opposite sign, and that's the way that you set up your two inequalities. You solve them, and the solution should always be disjoint, which means that they should always point opposite of each other. That's the way that you should always, your answer should always be represented in this fashion. Alright, and then in case 3 we have the absolute value is less than k. Okay, so think of this when you see this sign right here as and, less than, so it kind of almost goes together there. And the reason why I'm saying it's the and case is because we're going to say ax plus b is greater than negative k and it's less than k. So that's kind of why we say the word and here. So if you have an absolute value that's less than k, the way that you set it up is you do the opposite of this and put negative k. Do that inequality symbol ax plus b inside of here, and then same inequality, and then k, and then you solve for k. And the way that the answer should always look is it's in between. X is always going to be in between two values, which is always going to be a solid line. So this is actually a really nice chart that will be very helpful here. So let's go and do an example here of an equation. A half x plus 3, or the absolute value of a half x plus 3 equals 2. So we have to create our two equations. So we have our first one, a half x plus 3 equals 2. And then we have the other one, or we have the exact same thing inside of the absolute value. And now that's going to equal negative 2. Okay? And now all we're going to do is now solve for x for each of these. So we're going to subtract 3. We have a half x equals negative 1. We want to solve for x here, so I'm going to multiply both sides by 2 because I want to get rid of that 2 right there. So I get x equals negative 2, and that will be one of our answers there. Over here, let's do the same thing, subtract 3. Alright, so we'll get rid of the 3 there, so we have a half x equals negative 5. And I want to again multiply by 2, so x is equal to negative 10. And what's really nice is that we could always check our answer here. So a half times negative 2 is negative 1, and negative 1 plus 3 is 2, and the absolute value of 2 is 2. Bing! Let's try negative 10. A half times negative 10 is negative 5. Negative 5 plus 3 is negative 2. Absolute value of negative 2 is 2. Bing! So we checked your answer by plugging it back in. So it says to solve and graph. So we solved it. And so all we got to do is just make a number line. And again, since these are just individual values, the answer is just a point at that exact value. So we have -2 and then -10. So the answer is -10 and then -2. And there is no line connecting these because it's only these two individual exclusive values.